Hi guys, welcome to this Easy Maths video, and today we are looking at the 2019 Intermediate Maths Challenge, questions 21 to 25. Question 21, the diagram shows a right-angled triangle PQR. Point S is the midpoint of the side QR, and tan of the angle QPR, which is equal to 3/2. What is the value of sine of the angle QPS? We've got answers as A, which is 1 over root 3, B is 1 over root 2, C is a half, D is 3/5, or E is 4/5. Now, we're told in the question that S is the midpoint of QR, and we're told that tan of the angle QPR is equal to 3 over 2. Now, we know when we find the tan of an angle, we take the opposite side over the adjacent side. So the opposite side is QR, so I'll get rid of that. So we can say that QR is 3, and the adjacent side is the base of the triangle, which is QP, so this is going to have a length of 2. Now we're trying to find sine of the angle QPS. Well, the angle QPS is this angle here. Now sine is the opposite side of a triangle divided by its hypotenuse. So the opposite side is half of 3, because we know S is the midpoint of QR, so that's going to be 3 over 2. Now, we don't know what the hypotenuse is, but we've got the opposite side and we've got the adjacent side. So using Pythagoras, we can work out what the hypotenuse is. So PS is going to be the square root of 2 squared plus 3 over 2 squared. 2 squared is 4, plus 3 over 2, which is 9 over 4. And if we simplify this, 4 can be rewritten as 16 over 4. And 16 over 4 plus 9 over 4 is 25 over 4. And we can square root both the numerator and the denominator of this fraction. So the square root of 25 is 5, and the square root of 4 is 2. So now we've got our opposite side and our hypotenuse. So sine of QPS is going to be equal to the opposite side, which is 3 over 2. So 3 over 2, and then the hypotenuse, which is 5 over 2. So divide that by 5 over 2. Now, when we divide two fractions, we take the first fraction and multiply it by the reciprocal of the second fraction. So this is going to be the same as 3 over 2 times 2 over 5. And what you should be able to see is these 2's are going to cancel out, and we're going to be left with 3/5. And we've got an answer for 3/5, which is answer D. So therefore, our final answer is D. Question 22. 4 of the following 6-digit integers are always divisible by 7, regardless of the values of the digits P and Q. Which of the following is not necessarily a multiple of 7? We've got answers A, B, C, D, and E. Now, the question says that 4 of the 6-digit integers are always divisible by 7, regardless of the values of the digits. So that means we can use any values for P and Q. So I thought to myself, let's keep it nice and simple and use 2 of the easiest numbers that we can work with. So I said let P equal 1 and Q equal 0. Okay, and so I'm basically going to replace P and Q with 0 for each of these examples, A, B, C, D, and E, and test whether they're divisible by 7. And the one that isn't divisible by 7 must not be a multiple of 7, so that will be our final answer. So if we look at A first, A is PQQ, PQQ. So that's 1 followed by 2 zeros, followed by 1, followed by another 2 zeros. Now, I'm going to simplify this into 2 multiples. So I'm going to write this as 1001 and 100, because I know 1001 multiplied by 100 will give me 100,100. So the thing is, I know that 100 is not a multiple of 7, but I don't know whether 1001 is. So I'm going to test whether 1001 is a multiple of 7. If it is, then that means 100,100 is also a multiple of 7. What I'm going to do is I'm going to test whether 1001 is divisible by 7. So I can do that by using the method of short division. So I say how many 7s go into 1? That's 0. How many 7's going to 10? That's 1 with a remainder of 3. How many 7's going to 30? That's 4 with a remainder of 2. And how many 7's going to 21? That's 3. So therefore, 1001 divided by 7 equals 143. You can say that 143 times 7 gives us 1001. So therefore, if 1001 is a multiple of 7, then 100,100 must also be a multiple of 7. So we can tick A off. Now, if we have a look at B, B is PQP QPQ. So that's going to be 10, 10, 10. Now, I know that 101,010 can be split into two factors, which can be 10,101 and 10. Now, I know 10 is not a factor of 7. But let's test whether 10,101 is a factor of 7, so we can use short division again. So I say how many 7's going to 1, that's 0, how many 7's going to 10, that's 1, with a remainder of 3, how many 7's going to 31, that is 4 with a remainder of 3, how many 7's going to 30, that is 4 with a remainder of 2, and how many 7's going to 21, that is 3. So I know that 1,443 times 7 gives me 10,101. So therefore, 101,010 must be a multiple of 7. So we can tick B off. Now, if we look at C, well, you should be able to see that C is QPQ PQP. Now, if we go back to the start of the question, we made up our values for P and Q. And B and C are basically the exact same result. It's just that P and Q have been reversed. So what that means is if I made P equals 0 and Q equals 1, then my result for C is going to be the same as my result for B. So therefore, I can say without doing any workings that C must also be a multiple of 7. So I'm going to tick that off. What about D? Well, D is PPP, PPP. So if I do D down here, that's going to be 1, 1, 1, 1, 1, 1. Now let's test whether this is divisible by 7. So we can use the bus stop method. 1, 1, 1, 1, 1, 1. How many 7's going to 1? That's 0. How many 7's going to 11? That's 1 with a remainder of 4. How many 7's going to 41? That is 5 with a remainder of 6. How many 7's go into 61? There's 8 with a remainder of 5. How many 7's going to 51? That is 7 with a remainder of 2. How many 7's going to 21? That is 3. So therefore, 111 is equal to 15,873 times 7. So therefore, D is a multiple of 7. So I can tick D off. So that leaves us with E. Now, if we test E, that is 111,000, which if we split into two factors is 111 times 1,000. Now, I know that 111 is not a multiple of 7, and I also know that 1,000 is not a multiple of 7, so therefore E must be our final answer. So therefore, our final answer equals E. Question 23. The diagram shows a triangle with sides n squared plus n, 2n plus 12, and 3n plus 3. What is the sum of all the values of n for which the triangle is isosceles? We got answers as A is 7, B is 9, C is 12, D is 13, or E is 16. Okay, so we know for this triangle to be isosceles, two of the sides have to be equal. So that means we could either have n squared plus n is equal to 2n plus 12. We could have n squared plus n equals 3n plus 3. And finally, we could have 2n plus 12 is equal to 3n plus 3. And now what we need to do is we need to solve each of these equations for n, substitute the value of n into each of these expressions for each of these side lengths, and then work out whether they form an isosceles triangle. So if we solve this first equation, n squared plus n equals 2n plus 12. We subtract 2n from both sides, we're going to get n squared minus n, then we can subtract 12 from both sides, so we get minus 12 equals 0. So if I factorise this, I get factors of 4 and 3, and that's going to be n minus 4 multiplied by n plus 3. That's all equal to 0, so that means n equals 4 or n equals minus 3. Now what I need to do is I need to substitute these values of n back into the expressions for each of the side lengths of the triangle. So let's use when n is 4. So we're going to have 4 squared plus 4, which is going to be 20 for this side. Then we're going to have 3 times 4, which is 12, 12 plus 3, which is 15 for this side. And then we're going to have 2 times 4, which is 8, 8 plus 12, which is 20. Now we can see that this triangle, with side lengths of 20, 20 and 15, satisfies an isosceles triangle because n squared plus n is equal to 2n plus 12, and the third side is smaller than the other two alternative sides, which means that this triangle satisfies something known as the triangular inequality theorem, where one side of the triangle has to be smaller than its two other sides. So n equals 4 does satisfy an isosceles triangle. Now what about n equals minus 3? If we rub these out, for n squared plus n, we're going to have minus 3 squared minus 3, so that's going to be 9 minus 3, which is 6. And substitute that into 2n plus 12. We're going to get minus 6 plus 12, which is 6. And then substitute that into the bottom length. We're going to get 3n, 3 times minus 3, which is minus 9, plus 3 is minus 6. Now, the problem with this is we have a negative side length, and we can't have a negative side length. All of our side lengths have to be positive. They have to be greater than 0. So therefore, n equals 4 does work, but n equals minus 3 does not work. Okay, so let's have a look at the second equation, n squared plus n equals 3n plus 3. Well, first we need to solve this equation. So we're going to subtract 3n from both sides, so we get n squared minus 2n, and we can subtract minus 3 from both sides, so we get minus 3 equals 0. Right, and this equation is going to have factors of 3 and 1, and that's going to factorise to n minus 3 multiplied by n plus 1 equals 0. So n has values of 3 or n equals minus 1. Now let's substitute these values into our triangle. So if I rub these out, we're going to have 3 squared plus 3, which is 12. We're going to have 2 times 3, which is 6, plus 12 is 18. And then 3 times 3, which is 9, plus 3 is 12. Now, here we can see that n squared plus n is equal to 3n plus 3, and the other side length of 18 satisfies this triangle inequality theorem, because the side length of 18 is smaller than the sum of the other two sides, which is 12 plus 12, which is 24. So n equals 3 does satisfy an isosceles triangle. What about n equals minus 1? Well, for n squared plus n, we can have minus 1 squared, which is 1. Minus 1 is 0. Now I can tell you, without working out what the other sides are, that's an issue straight away. Because if we've got a side length of 0, that means we don't have 3 side lengths, we're going to have 2 side lengths, which means that it's not even a triangle. So an isosceles triangle does not satisfy n equals minus 1. So we can tick n equals 3 and cross n equals minus 1. What about the last equation? 2n plus 12 equals 3n plus 3. So again, we can solve this equation by subtracting 2n from both sides. So we get 12 equals n plus 3. And then we can subtract 3 from both sides. So we get n equals 9. Now let's substitute this value of 9 into our expressions. So for n squared plus n, we're going to get 9 squared plus 9, which is 81 plus 9, which is 90. Then for 3n plus 3, we're going to get 3 times 9, which is 27, plus 3 is 30. then for 2n plus 12, we're going to get 2 times 9, which is 18, plus 12 is 13. Now, we can see that 3n plus 3 is equal to 2n plus 12. That's correct. However, if we look at the other side length of 90 for n squared plus n, you should be able to see that 90 is bigger than the sum of the other two sides, because the sum of the other two sides is 30 plus 30, which is 60. So this triangle doesn't support the triangle inequality theorem. So that means it can't be a triangle. It cannot be an isosceles triangle. So therefore, n equals 9 does not work. So let's have a look for which values of n an isosceles triangle works. Well, there's only two values, n equals 4 and n equals 3. And we need to work out what is the sum of all the values of n for which the triangle is isosceles. So the sum is going to be 4 plus 3. So say 4 plus 3 equals 7. And we've got an answer for 7, which is answer A. So therefore, our final answer equals A. Question 24. When 5,655 is divided by a 2-digit positive integer n, the remainder is 11. When 5,879 is divided by the same positive integer n, the remainder is 14. What is the sum of the digits of n? We've got answers as A is 6, B is 7, C is 8, D is 9, or E is 10. The first thing we can do is work out what n might be. Now, we know that when 5,655 is divided by n, we get a remainder of 11. So what that means is if we do 5,655 minus 11, which is 5,644, 5,644 must be a multiple of n. Now we can say the same for 5,879. So 5,879 minus the remainder of 14, which gives us 5,865. Well, 5,865 must also be a multiple of n. If both 5,644 and 5,865 are multiples of n, then what we can say is their difference, 5,865 minus 5,644, which gives us 221. Well, 221 must also be a multiple of n. Now, because we know that the difference, 221, is a multiple of n, well, we just need to factorise 221. And we can factorise it using a prime factorisation tree. We're going to go through all the prime numbers and see whether they're prime factors. So first prime number is 2. We know 2 is not divisible by 221 because 221 is an odd number. So it's not 2. What about 3? Well, we can test whether 3 is a factor of a number by adding the digits of that number. And if the sum of those digits is a multiple of 3, then 3 must be a factor of 221. Well, the digits are 2, add 2, add 1, which gives us a total of 5. 5 is not a multiple of 3, so 3 cannot be a factor. It can't be 5 because 221 does not end in a 0 or a 5. 7, there isn't really a test for 7, you just got to do a bit of trial and error. So if we use the bus stop method, how many 7s go into 2? That's 0. How many 7s go into 22? That is 3 with a remainder of 1. How many 7s go into 11? Well, I know I'm going to get a remainder there, so 221 is not divisible by 7. Now, is 221 divisible by 11? Well, we know it's not divisible by 11 because if I do 11 times 20, I know I'm going to get 220, which is 1 off of 221, so it can't be divisible by 11. So my next prime number would be 13. Now, and if I use the bus stop method, how many 13s Going to 2, that's 0. How many 13s going to 22? That's 1 with a remainder of 9. Now I know 13 goes into 91 7 times. So my two factors must be 13 and 17. They are my two prime factors. Now I can only have one value of n. Well, we'll need to add up those digits of n. So my answer is either going to be 13 or 17. But in order to check which is the right answer, I need to see whether 13 or 17 are factors of 5644 and 5865. So I'm going to start off with 13. So let's test whether 13 is a factor of 5644. So I'm just going to go straight in with the bus stop method. So how many 13s going to 50? How many 13s going to 56? Well, I know 13 times 4 is 52. That's going to give me a remainder of 4. How many 13s going to 44? 13 times 3 is 39. It's going to be 3 with a remainder of 5. And then how many 13s going to 54? Well, I know 13 does not go into 54, so I'm going to end up with a remainder. So what that means is 13 is not a factor of 5644. So n cannot be 13, so it must be 17, but I'm going to do a test for 17 to double check. So let's do the bus stop method on 5644. So how many 17s going to 5? That's 0. How many 17s going to 56? 17 times 3 is 51, so that's going to be 3 with a remainder of 5. How many 17s going to 54? That's going to be 3 with a remainder of 3. Now, I know that 17 times 2 is 34. So, 5644 divided by 17 equals 332. And because I've got no remainder left over, 17 must be a factor of 5644. Now, it's also got to be a factor of 5865, so let's just test that. 5865. How many 17s go into 50? How many 17s go into 58? 3 with a remainder of 7. How many 17s go into 76? Well, I know 17 times 4 is 68. So that is going to be 4 with a remainder of 8. And then how many 17s go into 85? Well, 17 times 5 is 85. So I know that 5865 divided by 17 is 345. So 17 is also a factor of 5865. So 17, so n must be equal to 17, but now I've got to add up those digits, and that's going to be my final answer. The digits are 1 and 7, so we can say 1 plus 7 is equal to 8. And we've got an answer for 8, which is answer C. So therefore, our final answer equals C. Question 25. The diagram shows 3 touching semicircles with radius 1 inside an equilateral triangle, which each semicircle also touches. The diagram of each semicircle lies along a side of the triangle. What is the length of each side of the equilateral triangle? We've got answers as A is 3, B is 13 over 4, C is 3/2 of root 3, D is 2 root 3, and E is 4. Okay, so the way to answer this question is we need to concentrate on one of these side lengths, and the side length that I'm going to be focusing on is this bottom one down here. Now I'm going to try and sort of divide this equilateral triangle into smaller triangles. So the way I thought about this is if I connect the centre of this semicircle to this side length, this is just my radius, so this is going to have a length of 1. Now what I can say is that this side length of my equilateral triangle is kind of like a tangent, and from GCSE maths with circle theorems you should know that the tangent to a circle is always perpendicular to its radius, so that means that here we're going to have a right angle. Okay, so that's quite interesting, because now if I connect these two sides, I've got my first triangle which makes up this bottom side length. So if I draw that triangle down here, got a right angle here, we've got a side length of 1. Now, of course, this is an equilateral triangle, which we're told in the question. And we know that equilateral triangles have equal angles of 60 degrees. So we know that this angle here is going to be 60 degrees. No, this angle here is going to be 60 degrees, and this angle here is going to be 60 degrees. So if I label 60 degrees on this triangle here, it's going to be down here. Okay, so that's our first triangle. The second triangle you can form by connecting the centre of this semicircle to this semicircle. Because the radius of each semicircle is 1, this whole length here must be 2. Now, this semicircle also has a radius of 1, so if we draw a line connecting this centre down to this side length, this is going to have a length of 1. Now, you should be able to see that we've got another triangle here. There's also going to be a right angle here. So if I draw the second triangle here, this is another right angle triangle, but this time we've got a side length of 2 here and a side length of 1 here. And now our final triangle is in the bottom right hand corner of this equilateral triangle by connecting these lines here. So if I draw it down here, it will look something like this, where we've got a right angle here, we've got an angle of 60 degrees here, and then we've got a side length of 1 here. The question says that we need to find the length of each side of the equilateral triangle. Well, you should be able to see that this side length here, this side length here, and this side length here, if we add those side lengths together, it's going to give us the total side length for this equilateral triangle, because the base of this equilateral triangle is made up of these 3 triangles. And we can work those out using trigonometry and Pythagoras' theorem. So if we look at triangle 1, we can use trigonometry. So if we think about SOHCAHTOA, we're going to use sine equals opposite over hypotenuse. So that's going to be sine 60 equals opposite, which is 1 over our hypotenuse, which I'm just going to call hype for short. Now I can rearrange this to work out what the hypotenuse is. The hypotenuse is going to be 1 over sine 60. Now, this exam is non-calculator. So if we use the trig triangle, that looks like this, with angles of 60 degrees here, an angle of 30 degrees there, and then it has a side length of 1 here, a side length of 2 here, and then using Pythagoras' theorem, we have a side length of root 3 here. So sine 60 is equal to opposite over hypotenuse, which is root 3 over 2. Okay, so now we can say that the hypotenuse is equal to 1 over root 3 over 2. And that simplifies to 2 over root 3. Right, so that is the length for the hypotenuse of this first triangle, 2 over root 3. Now on the base of the second triangle, well, we can work that out using Pythagoras' theorem. It's just going to be square root of 2 squared minus 1 squared, which is root 4 minus 1, which is root 3. So the base is root 3. Now on the base of this other triangle, well, that's going to be opposite over adjacent. So that's going to be tan 60 equals opposite, which is 1 over the adjacent. Well, the adjacent is going to be equal to 1 over tan 60. Tan 60 is opposite over adjacent, which is root 3. So the adjacent side is equal to 1 over root 3. Right, so the base of this is 1 over root 3. Now we just need to add 2 over root 3 plus root 3 plus 1 over root 3. So 2 over root 3 plus 1 over root 3. Now, these fractions, which have a denominator of root 3, we need to simplify those by rationalising the denominator. So 2 over root 3 we can multiply by root 3 over root 3. So we get 2 root 3 over 3, which is 2/3 of root 3. 1 over root 3 times root 3 over root 3 equals root 3 over 3, which equals 1/3 of root 3. We can then add all of these results together. Now when we get 2/3 of root 3 plus 1/3 of root 3, that's going to give us root 3. And then we're going to get root 3 plus root 3, which is 2 root 3. And we've got an answer for 2 root 3, which is answer D. So therefore, our final answer equals D. Thanks for watching the video, guys. Don't forget to subscribe to my channel. I've also left a link in the description to my website, and you can also check out any other videos from my YouTube channel on this page.